All right, so this is Lab 1 Charge Tapes for Physics 2212 by William Brantley. So the introduction to this lab. So the purpose of this lab, we're going to create 2 charged pieces of tape and observe their interactions. Then we're going to determine the amount of excess charge on each piece of tape. Finally, we're going to use GlowScript to simulate the interactions and basically make a computational model to see how accurate or compare our results to the experimental results. Fundamental principles we use are going to be Newton's second law, Coulomb's law, electric force, gravitational force. And just a quick overview of the results. So the tapes repel each other, which means they have like charges. The charge on the tape we used for coding part 1, we calculate as 1.4 times 10 to the negative 8 newtons per coulomb. And then the magnitude of the missing electrons is 8.75 times 10 to the 10th. Assumptions for this lab. So each U-tape has around the same net charge, which is evenly distributed across the length of the tape, and then each tape represents a single point charge. For the experiment, so our initial conditions, we're going to use 2 pieces of tape. They're going to be equal in length, and the third piece of tape is going to be stuck to the desk or table. And then the system and surroundings. So the system is obviously the tape A and B. Surroundings are going to be everything else in the room. So we're go through our experimental results. So observations first. After observing interactions between tapes, we see that tapes are positively charged. Data and measurements. So the mass of the tape is 0.002 kilograms. The length of the tape is going to be 0.2 meters. Width of the tape, 0.02 meters. Surface area, 0.04 meters squared. For calculations, we calculated gravitational force is 0.00196 newtons. The U-tape charge is going to be that 1.4 times 10 to the negative 8th. Missing electrons is going to be 8.75 times 10 to the 10th. And then electrons per atom, that ratio that we were supposed to calculate is going to be 1 electron per negative 4.5 times 10 to the 6 atoms. So computational model part 2. So this is the coding part 1. So we established our gravitational force, our electric force. We put all of our data, like our mass, in, and then we use the E field function that we defined. And we calculate the charge, and you can see the charge on the tape is those numbers that we went through in the last slide, 1.4 times 10 to the negative 8 coulombs. And then our coding point computational model part 2 is going to be where we look at it as line charge. And the charge we get on that is 2.795 e to the negative 8. And we are going to establish that this is a more accurate number than the first part. So what if, so our discussion questions, so what if the electrons are negatively charged and protons are positively charged? And what if their signs were reversed? And how would this change the observation? So all of the experiment would basically stay the same like it is, but the tapes would be negatively charged and the tapes would still repel one another. And then why? Compare the estimated value of the charge when you use your experimental data to produce a point charge model in the first part of the code to the second model. So we kind of talked about that last slide. So the line charge model accounts for net force and electric field throughout the curvature of the tape. So this is going to produce a more accurate number, and that's that 2.795 e to the negative 8. And just lastly, the conclusion, possible sources of error. We got inaccurate measures of tape length, width, or mass, and then inaccurate measurements of distance between tapes. Thank you.